In this video, I'm going to focus exclusively on setting up environment variables. Um, I know I mentioned in the previous video that I was also going to set up Mailgun, but I wanted to make this video more digestible and separate doing two things into two videos. So yeah, I'm going to focus only on environment variables and how to do it effectively with TypeScript. Again, part of this video series is to focus on doing excellent TypeScript and how to leverage the type system as much as possible. So in this video, I'm going to demonstrate how to use TypeScript in a way that allows us to have type or compile time guarantees around our environment variables. And then yeah, in the following video, we'll use those environment variables to start setting up Mailgun and make an API request to Mailgun. So with that said, I do want to do something that I didn't show in the previous video, which is deploying our code. So in order to deploy our code, all we would do is go to what is it? Functions, and then run npm run deploy. So while that's running, I want to show you that I have a tag for the previous video. So again, if you're following along and you're not coding this from scratch, you can simply git checkout video 1. So I'm going to be tagging specifically the last commit of each previous video. So in this video, it'll be video 2. So let's see how this is going. So it's deploying our function. The other thing I want to do in the meantime, because I don't want to just wait around and sit around while that's going, is I want to open package. Actually, I like opening my files at the root of the project. So when I do that, there we go. Okay, so one thing I want to do that will help with productivity, so a little chore, is going to be to add a watch script. Okay, so let me go here and call it watch. It's going to be the TypeScript command, but I'm going to have a flag here that says watch. What this command is going to do now is it's going to do the exact same thing as build, but it's going to watch for changes in the file system. And so anytime I modify a file and it changes and I save, TypeScript is going to automatically recompile for me, and it means that the emulator will serve the most recent files. It looks like our job was finished here. So there we go. Again, all I did was run npm run deploy. There are some pre-deploy scripts that run. The first one is linting. The second one is the actual build itself. So the TypeScript code gets turned into JavaScript and then it gets uploaded. So what we can do is we can check out our function. So let me go to my console. Let me first see my other window if that's the right user. Okay, here. So okay. So here, if I click on newsletter app and I go to functions, you'll see that I have a hello world function. So now I can copy this, go back to my terminal, and well, let me go here, and I can do curl and get the hello world now from a remote URL. So that's done. We're setting up a watch script, and yeah, I guess now I can set up the server or emulator. So let me do that. Serve, and I'm also gonna run watch. So let me reorganize my tabs here. I'm gonna rename this to TSC watch. So I'm just renaming my tab here at the bottom. This is specific to my terminal. And what am I gonna do? I'm gonna run npm, so a little script inside functions. So let me do that again. And I'm gonna run the watch command that we just created. So I'm gonna run that, and you can see that now it's starting compilation in watch mode, and it's going to work in tandem with my emulator. Okay, so let me demonstrate that for you. If I go to the index, we see that on line 8 there's the hello from Firebase text that gets sent out to a consumer. So let me copy this and run curl here again. Okay, that's expected. But now if I do something like that, what happens is we get the changed code. So it's almost as though we're developing in JavaScript now. You know, like there's no concern that we have around compiling our code. It's just constantly being recompiled. So it's a really useful thing to have. So again, the way that that works is that I have a watch script that compiles to the output directory, and then the emulator is immediately picking up that code. There are some circumstances where the emulator doesn't pick up the changes, and I haven't yet figured out like in what situations that happens. I just know that it does happen sometimes. Let me actually, okay. Yeah, so it does happen sometimes. Sorry, I'm just playing around my volume. Okay, there we go. So again, sometimes when you're working with TypeScript and your watch script isn't being, or your compiled output isn't being picked up by the emulator, I don't have an answer for you. I'm not sure why that is the case, but 90% of the time, this watch script with the emulator should suffice. Okay, so now we can talk about environment variables. So I'll link this in the comments, but just know that there's a whole section on environment configuration for Firebase. And I believe they talk about runtime config somewhere. Maybe it's not in here, but anyways, I'll demonstrate that. So we're going to use this command only for our production environment. And with this command line interface, we're going to be able to set whatever environment variables we want. So the way it works is that you specify the operation that you want to do with Firebase. Okay, so we're in this case saying we want to set up some configuration. Then there's a like a service name, or think about it as a namespace. So for this particular service, there are two environment variables. The first one is called key with the value of the API key, and the other environment variable for this same service is ID with the value of client ID. I'm making the assumption that the values should always be strings, and we're gonna create types for that in a minute. So we're gonna always expect that the value is a string. Okay, so this is how we're gonna set up environment variables from production, but how is it gonna work locally? So I'll also find the documentation for this, but right now I can't find it. The way it works locally is that we have a file called runtime config. So let me go ahead and create that. So right now I'm in the functions directory, and in the functions directory, I'm going to create a new file, and I'm going to call it .runtime config.json. Okay, so again, it's inside your functions directory, and it's called .runtime config.json. So I'm going to go ahead and create that, open it up, and it's going to be a object. Now, if we go back to our documentation, we see that there has to be a namespace or a service name. So for our use case, all we need is one namespace, and I'm personally going to call it newsletter. You can call it whatever you would like. And in here, we're going to have our environment variables. So for now, we're going to just have a placeholder, ABC123. Okay. And in here, we're going to store our mailgun information, which I'll demonstrate in the next video. But for now, I want to focus on just setting up the environment variables, and again, parsing and validating that information in a type-safe way, or leveraging TypeScript as much as possible. Okay, so we've done that. And the other thing is, we don't want to commit this this information because it's developer specific. So imagine you're working at a company and every developer maybe has their own Mailgun API tokens, or their own developer specific API keys that identify them. So you wouldn't want to commit that. What you would want to do is do something like, let's see, maybe you'd want to have a README. So maybe top level README. And in the README, you would say, getting set up, add a runtime config.json file to your functions directory. And I'll update this with the proper documentation once, maybe in the second video or in the next video. But in the meantime, I'll close these windows. All right, so here we are. And now I want to demonstrate a very simple way of reading environment variables. So let's go here. And the way you read environment variables is very straightforward, thanks to Firebase. So all you do is you say functions. Let me first clean up the formatting here. I should probably set up prettier or some other formatter. Okay, so anyways, again, as I was saying, the way that environment variables are read is by using this following API. So remember, I've set up function, or I've imported functions, and on line 9 I'm going to do functions.config, and then I'm going to do the name of the service. So in this case it's going to be newsletter. Okay, so remember I called it newsletter. And then I'm going to reference, I can reference a specific value, so in my case it's placeholder, but I just want to print it out to show you what it looks like. So I'm going to do that, and I'm printing out the whole object for the newsletter service. So it should print out an object with placeholder as the key and ABC123 as the value. So we have watch mode running, so I shouldn't even need to do anything. It should just work. If I go over here and call my endpoint, we're going to see that we got the hello from Giorgio output, which is the expected behavior, right, on line 11, and we should also get a log. So let me go to my other tab, and there we are. We've gotten the expected output. So now that we know that we're reading the correct values locally, we can move on and create a module that will give us types for these environment variables. So let me demonstrate that. So inside functions src, I'm going to create a new file, and I'm going to call it env.ts. Oh yes, I I got a little sidetracked. So I don't want to move on to this step yet until I've done a little bit of chores for the runtime file. So remember, I was saying that this is developer specific, and I got totally sidetracked and I didn't explain what I wanted to do with that fact. The first thing I want to do is I want to ignore this file. Also, I'm not sure why there's a get ignore at this. I just want to have one get ignore, not two. I guess I'll deal with that afterwards. But anyways, what I'll do here is, oh, there we go. Firebase config. Yeah, sure. Firebase functions, and then runtime config.json. Okay. So what I've done is I've gone to the get ignore, okay, at the root of the project, and I've ignored it because I don't want my specific config to be pushed to the repo. I want every developer to have their own. And something that might be useful to do is to have like a placeholder. So something you see sometimes in projects is you'll see like .example .runtime config, right? And then that's what you would use to create your own runtime config. But in my case, I'm not going to do it. It would be a good practice though. Okay, so I've added this, so I don't want to commit it. Whoopsies. And the other thing I want to do is I also want to ignore it from being uploaded to Firebase itself. So remember, if I go to the documentation I was mentioning that there's a whole different way of setting environment variables for like a quote-unquote production environment or like a remote environment. So we're not going to leverage the runtime config for the remote environments. So let me go back here and let me go to our handy dandy file called firebase.json. Okay, so you should have a firebase.json file at the root of your project, and it should look somewhat like this. So what we're going to do is have another field here for the functions object and call it ignore. And ignore takes an array of different files you want to ignore or entire directories. So for the sake of safety, I'm going to add two values which are basically the same. I'm going to be calling runtime config here .json, and I'm going to do the exact same thing again, but inside functions. So this is just to be super safe. Runtime config .json. Okay. Let me just double check that they are the same spelling. They are indeed. Okay, cool. Let me close this. That's done. So if I go to my terminal and I clear this and I call it get status, we should not be seeing runtime config anywhere here. Package JSON. Okay, that makes sense. That makes sense. Great. All right. So I only see files that should exist in or should be or that Git should be aware of. And that's great. So now we can actually move on to the creation of a sort of like type-safe parser for environment files. So let me close this and also this. Whoops. Okay. So the first thing I want to do is I want to import the functions module. I believe that's it, right? Firebase functions. Yeah. I also don't use semicolons, so anytime you see semicolons, that's because it was generated by the CLI. I kind of adhere to this way of coding called standard JS. Just know that you can basically get away with not writing semicolons because they get automatically inserted at runtime. Okay, so where was I? We're going to create a env.ts. The way I want to think about this is, I guess we can start from the basics, right? So I could do something like this. Export const placeholder, right? Because we're going to have an environment variable called placeholder that we want to bring in to our system and be usable, right? So like, for example, in another file, other file.ts, right? Like if we just imagine this to be a different file, I can do something like import placeholder from env, right? That's the API I want, right? And then that way you don't have to be coupled to the Firebase Firebase API, right? So like if you wanted to swap out the way that you do environment variables, it's all in the env file, and the consumer of these environment variables isn't aware of the implementation. So that's one benefit. And then here you can just start doing a whole bunch of different imports. You're not limited. Okay, so that's the API I'm looking for, right? So that's sort of the context as to what I want. So the naive way would simply be to do something like this: functions config, and then what was it? Newsletter, and then placeholder. Okay, so this works already. However, let's see what this value is. I'm going to hover over it, and we're going to see that currently TypeScript has no way of knowing what this value is. So that's where the any type comes in. The any type is meant to represent dynamic code, right? So remember that JavaScript is dynamically typed, and any variable can be of any type at any time, and it can change. However, that's great, but that can lead to issues when we make assumptions about our code. So for example, in this particular case, we are currently assuming that this variable called placeholder is holding a string, but it could very well not be a string, right? Like if I mistype this, if I, just forget to type the entire word placeholder, we're still going to assume that this is going to be a string. And in fact, this is going to compile. So I can demonstrate that to you. If I go to my next tab, you see that this is still compiling. Conversely, if I do something like const val equals, or it's supposed to be a number, and I do 1, 2, 3, 1, 2, 3, and I go to my next tab, we're getting compiler errors. And this is good. Like I think sometimes people see compiler errors and they're like, oh no, like this sucks. But this is great because you're catching a bug before your users find it. And eventually, so the idea is to sort of become a friend with a compiler and have the compiler guide you in the building of great functions or great code. So always thinking in types really helps, or thinking in types first before implementing things. And so that's kind of where my next point is. Oh, actually, another example before I move on to my next point, which is although this wouldn't fail at runtime, so if we see the output here, we see that things are working fine still. Actually, let me import it. So let me go to import placeholder from env. And let's log it, sure. Okay, so if I call this, it's undefined. Okay, that's unexpected. Let's see. Oh, there we go. See, I forgot to rename this back to placeholder, and I'm getting unexpected behavior already, right? So we want to avoid that. Or like, for example, oh, what did I do? So we have, oh, index. Okay, so we want to avoid situations where you're surprised like that. Like I was genuinely surprised, and I totally forgot that I didn't rename this back to the correct name, which was placeholder. Okay. We want to prevent that as much as possible. The other thing that I wanted to show you was this. Like if I, whoops, if I mistype this, okay, and I go back to the compiler output, the compiler can't help us here either, okay? So TypeScript says, yep, you're good. You can ship this to production, you're great. And uh-oh, you ship this to production and now your users are pissed off, okay? So again, how do we deal with this? You want to think in types. The first thing I want to do is think about what the shape of, what is it? This value is. I should say newsletter. Okay. So if I remove all this, what should the type of this be, right? This should be some object with keys and strings. Okay. I want to make a type that represents that. So what I want to do is create a type alias here called env-config. And it's going to represent a object exactly like on line 8. So I'm going to use a type called record. And I'm going to say string for the keys and unknown. Okay. So that's what this is going to be. Let me see. Another way to code this, which is totally fine, I just personally like using this record type. It's just more sort of terse. Another one would be env, so let me do env-config 2, and I can type like this. They're exactly the same, and in fact, I think the implementation for record is this. So if I go into here, yeah, see, it's the exact same thing. There's some weird Microsoft Windows key codes, but don't worry about that. It's the exact same thing. So you have an object with the keys and the type for the value. So anyways, I'm going to stick with this type. And now we have an option. One thing to do is to do a typecast. So that's fine. If I hover over this, I'm apparently okay, right? But the issue is that you've basically told the compiler, hey, I know what I'm doing. I am 100% sure that this is good. Just leave me alone. I'm going to figure it out. So a typecast is dangerous in that sense because you're telling the compiler to no longer help you and you're just leaving it to to people to hopefully get it right. And it works fine until you're tired or you're not paying attention or you're working in a team where you're trying to move really quickly, right? So in situations like that, you will eventually hit a snag with the typecast, and the value at runtime will be different. So for example, again, if I mistype this, the compiler still thinks that this is a record, but in reality, this is going to be undefined at runtime because I don't have a value in my config called newsler, right? Um, so again, what I want to do is I want to convert this any into a value of mconfig in a type-safe way. So the way I'm going to do this is I'm going to create a value or a function called is valid config. Okay, and I'm going to take a value of type unknown, and I'm going to say I'm going to return a boolean. Okay, so for the sake of simplicity right now, I'm going to return a boolean, but we're going to make that a bit better in a second. And the way that you check whether something is an object in JavaScript is as follows. So you do type of val equals object, and val does not equal null. So because for some weird reason null is an object in JavaScript. Okay, so once we call this function, right? So let's do this. There we go. And then way down here, that's what we have so far. Okay, so back to this, is valid config. Now I can pass in my newsletter config, right? Remember, this is an any type. And if it's not a valid config, I can throw an exception. What do I want to call this? Okay, so one little quick segue is that I mentioned at the start of this video series that I don't use side effects, I don't throw exceptions. But there is one exception, no pun intended, which is if you have, if your system is in a state that it shouldn't be in, then your system shouldn't be running in the first place. In low-level languages, that's called undefined behavior. So if you were to read like the C language specification, there's literally parts in that specification that say this behavior will be undefined if blah 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 blah. So there are conditions in C where like there's no sort of rules around the state of a program in C. This applies to other languages. Like you could have, in our example, or in our case, we would have undefined behavior if you don't have environment variables for Mailgun. Like how are you going to send emails to your users if you don't have, or like even subscribe? Like if someone wants to subscribe and you don't have the API tokens to interact with Mailgun, you have undefined behavior. Like what is your program supposed to do? And sending 500 response is fine, but like the user doesn't care. If the user sees a 500 or sees nothing, they don't care. It's not working to them regardless. So my point is, um, if you're in an undefined state, your program should stop running. So that's sort of my very opinionated point of view. And then the other thing is you should have error reporting, right? So in a production system, you need to stop your program running from doing unintended things or from having unintended consequences, but then also notify the engineering team. You don't want to just fail silently. You want to have a crazy alarm going, and your whole team needs to uh, jump on board and figure out the problem as quickly as possible. So anyways, uh, after that segue, if I do this, so I'm assigning the value of newsletter config to test just to hover over this. So this is kind of frustrating. We still haven't really solved our problem. The test variable is still an any type, even though we validated it. So again, this is still not like the desired outcome. Thankfully, actually I'm going to leave this here. So this leads me to my first big lesson here, I guess, with TypeScript, is that there's a feature in TypeScript that allows you to modify or to enhance functions like this. These validation functions can be enhanced in a very TypeScript specific way. So all you need to do is you need to, we're going to still return a Boolean, right? So like the implementation of this function is going to not change. It's not going to change. But the type annotation is going to change. So what I'm going to do is I'm going to tell the compiler, hey, if this function returns true, then this value is an end config. Okay? So all I've done is I've now provided extra information for the compiler to then tell us, oh, this thing, if this function returns true, this value parameter, okay, so remember, this value parameter passed down here is in fact an end config. So now if I go to line 19 and I hover over here, now we have proper type information. Okay, so the next thing I want to do is I want to individually test the values inside my object. So remember, oh, and I don't know if I mentioned this, but whenever you're validating data, you want to, or like working with data you don't yet know what it is, don't use the any type. Use the unknown type. I don't really want to get into it right now. That's a whole other segue, and this video is already getting kind of long. But unknown is a lot better, and it's a sort of like the type safe cousin of any. So anyways, the next thing I want to do is individually test the values of our environment. So for example, the placeholder value, we expect it to be a string. So I'm going to have a function called isString. And I'm going to do the exact same thing as I did on line 10. So it's going to be a very similar pattern. I'm going to have val unknown, oh, whoopsies, and I'm going to return something here. So if you're watching, I ask you, what should I return here? You can pause it. If not, I'm going to just do this right now. What I will do here is I'm going to say val is string. Okay. And all I need to do here is type of val equals string. The other thing to note is that this kind of type checking, so when you use type of, TypeScript is already going to infer this sort of return type for you. So remember, TypeScript has type inference. So it's really nice because in languages like Java, you have to always annotate your things, and so you end up with like a lot of noise in your code. Like types are a lot of noise and they take bandwidth. So if you can omit types, power to you. I also think that no types is great, but sometimes it can be dangerous. So here you can see the type annotation says that this variable is a function that takes an unknown value and returns a Boolean, and the meaning of the Boolean has like a connotation at compile time. If I remove this annotation, it should have the same type. So let's double check. Oh, it doesn't. That's actually surprising to me. I do this pattern a lot within like blocks of code, and within those blocks of code, the compiler is able to narrow down the type of a value. So I'll show you that throughout the videos. But anyways, we're gonna add this information the uh, to the return type, and let's continue here. So we have isString. Oh, and there's one last thing. So I want to have a function that returns a string, basically. So like takes a value from the config. So in this case, we're going to have, what is it? Yeah, it is placeholder, so that's already done. I want to have a function that returns a string or throws, like the above example here, if the value isn't a string. All right, so the way I'm going to do this, let's remove this test assignment. So I'm going to have another function called verify env, and it's going to take the name of that environment value. So it's going to be the name here, right? So in our case, do I have this here? So in our case, it's called placeholder, right? Well, I don't know why I opened this file. I could have just done, yeah, I could have just done this. So we're going to take the name, and I'm going to use a fancy way of saying the key of the object, or the name of the object. All right, so this is basically the same thing as saying string, right? So if I hover over env name, it is a string, and that type is being inferred because the key of record is a string. And I believe that's it. And it's going to return a string, remember? So it's saying I want a function that takes the value, or like the key, and returns the value if it is a string. Otherwise, throw an exception. Okay, so the first thing I want to do is I want to actually get the value out of the environment object. And the way I'm going to do that is I'm going to do newsletter config and env name. Okay, and at this point, this should be an unknown. There we go. And I'm going to call my utility function on line 19, and I'm going to say if it's not a string value, I'm going to throw an exception. Invalid env name. Let's see, can I wrap this? There we go. And we're going to log out the value as well. Okay. And if that doesn't fail, so like if we indeed have a string, then we return the value. Okay. And then what we can do for all of our environment variables moving forward is I can call this verify env, and then I can call, what's our first one called? Placeholder. There we go. And now, if I hover over placeholder, we have a string. Also, we don't have any type errors, and this is a stack trace from a previous exception, I believe. So let's just try it out. I'm gonna call curl. It's running, and we got our environment variable. Okay. Now lastly, let's try misspelling it. So let's, for example, say let's say we expect something else, like something more realistic, like mailgun API token. So let's say that this is indeed something we require. It's going to compile, which is okay, and I'm going to run the function. Oh, actually, there we go. Yeah, it's done. So what I wanted to show was our system wasn't able to start because it didn't meet the requirements for starting. So one of the requirements for starting the system was that you needed a Mailgun API token to start running the program, and it didn't, it failed, and then presumably at this point the whole engineering team would get notified and the issue would get fixed, and this would hopefully happen um, in staging. This does happen in production environments as well. Um, but yeah, I don't want to get into DevOps conversations, but yeah, so this is what I wanted to demonstrate. So now we have validation and we have a type-safe way of uh, extracting environment variables from disk or from the network, that sort of thing. So let me undo this. Is there anything else I want to talk about? No, I think that's it. So I'm going to tag this as video 2. In the next video, I'm going to talk about setting up Mailgun and sending API requests to Mailgun. And yeah, I'll talk to you later.